The following is a presentation of the Industrial Innovation Digital Futures project titled Towards Safe Smart Construction, Algorithms, Digital Twins and Infrastructures, presented by the Distributed Hybrid Systems Group at KTH Royal Institute of Technology. The project team is composed of academic and industrial partners, with three different schools at KTH represented: the School of Electrical Engineering and Computer Science, the School of Architecture and the Built Environment, and the School of Industrial Engineering and Management. Industry-wise, the project is represented by the companies Skanska, mainly focused on the construction part, and Ericsson for the networking infrastructure and services. To give some context to the project, construction sites nowadays have high carbon emissions, are not very sustainable, and require extensive manual intervention, which implies safety risk and complicates the task of quality control. Additionally, being mostly manual labor with a low degree of automation means that real-time monitoring is difficult to achieve, and the production cycle is therefore slowed down. This project aims to fully digitalize and automate the construction process based on the Skanska use case to produce reinforcement cages on-site through a multi-system setup. These cages are then filled with concrete and are used for the construction of different infrastructure projects, like bridges and tunnels. This multi-system setup is based on two subsystems, A and B, to produce the cages, and subsystem C to place them on-site. These subsystems are then controlled and monitored by three modules or work packages for multi-robot control, networking, and digital twin infrastructure that bring together the automation and digitalization to the subsystems. To have an agile development and validation, we established a multi-robot system for production in our lab at KTH. This testbed contains one ABB IRB 120 robot arm, one ABB IRB 1600 robot arm, and one UR5 robot arm. All the robots will be wrapped up as individual roster nodes, which will allow the robot arms to talk between them, resulting in a fully decentralized system, which is easy to scale. A digital twin model of the real robotic system has also been created inside the Unity 3D software, and it will be connected to the real robots through its own ROS2 node. This digital twin will show to the user everything that is happening on the system in real time, among other future tasks. Additionally, the 5G communication testbed at KTH R1 Reactor Hallen will also be used. Thanks to its modern 5G network with multiple radio configurations available, several experiments will be performed where the communication among the robot arms will be done through the 5G Wi-Fi network. Three work packages will be used to advance the state-of-the-art in smart construction thanks to the creation of a digital twin coupled with a real system, an optimized network infrastructure service tailored for the construction use case, and heterogeneous multi-robot task planning and control that considers spatio-temporal constraints. An additional fourth work package will apply these works into the specific smart construction case. This in turn will allow us to achieve the goals of the project, not only for the Skanska use case, but also for understanding 5G and B5G systems, and finally develop the consortium and attract more funding in the area. The three main work packages will be brought together into one distributed solution. The software loop will be as follows. A goal product, like the reinforcement cage, will be inputted into an offline planner which will generate an initial plan. This plan is then entered into an online adaptive replanner which will then send a corrected plan into the real robotic system. The output of this system will be measured and sent to digital twin as well as the replanner. The digital twin will then show the current execution to a human, who can insert new commands into the system, and an additional fault detection and isolation module will recognize early problems into the executed path. All of these problems, together with latency measurements and predictions, will be sent to the replanner to ensure correct and fast execution under minimum time delays. A 5G Wi-Fi network will be used to ensure communication among the different ROS2 services. Now I will show some recent achievements of the project. For the first work package, a digital twin using Unity 3D has already been created, which contains the three robotic arms and the gantry system as fully movable entities. Additionally, the ROS2 decentralized infrastructure has been set up, and ABB controllers have been tested and integrated with the real hardware. For the second work package, two works have already been published. The first one is a validation of latency predictions in a real-world scenario. The predictions were obtained through learning an EVM model with indoor latency measurements, which has better performance than current GMM state-of-the-art predictors as shown in Figure 1. The second publication is a novel delta algorithm for latency optimization through active intervention. This was done through active queue management schemes to optimize end-to-end delayed violation probabilities. As shown in Figure 2, delta outperforms current AQM skills substantially. The third work package has achieved the creation of temporal logic-based planners through metric interval temporal logic and time Petri nets to construct plans, and we are currently working on adapting these plans to account for faults predicted by the digital twin. These faults can then be fixed through the creation of corrective actions. Another alternative and current work is on the use of adaptive prescribed performance controllers to account for the faults on the systems in real time. Lastly, human-in-the-loop approaches have also been considered in a recently submitted publication, where human commands can be added in real time to the robot plan through spatiotemporal specifications. With this, the presentation is finished. I hope you enjoy and thank you for listening.